Grade 10 Relations and Functions Part 2. Welcome back to Djji Tutorials. Today we are discussing representing data using function models. Let's dive in. First, let's look at a mathematical model. This is a representation of a real-world system using mathematical concepts and language, often in the form of equations, graphs, or other mathematical tools. It helps in understanding, predicting, and analyzing the system's behavior, and can be used in various fields like science, engineering, social sciences, and even music. Some examples are population growth, relational behavior for a consumer, distance and rate, time and temperature, and expenditures and revenue. Here's a more detailed explanation. Abstraction. Mathematical models abstract away from the specific details of a real-world situation, focusing on the essential relationships and processes. Mathematical representation. The model uses mathematical tools, such as equations, graphs, or simulations, to represent the system. Purpose mathematical models are used for a variety of purposes, including prediction, making predictions about the system's behavior under different conditions. Analysis, understanding the factors that influence the system and how they interact. Simulation, simulating the system's behavior in a virtual environment. And optimization, finding the best possible way to operate the system. Some examples include physics, modeling the motion of objects using Newton's laws; economics, modeling market dynamics using supply and demand curves; engineering, modeling the behavior of structures using structural mechanics equations; and social sciences, modeling population growth using demographic models. Types mathematical models can be static, representing a system in equilibrium, or dynamic, representing changes over time. Modeling process. The process of creating a mathematical model involves identifying the system, formulating mathematical relationships, and then testing and refining the model. A functional model, in the context of representing data, is a structured way to illustrate how data is processed or transformed within a system. It focuses on the how of data manipulation, showing the operations and functions that convert input data into output data. Alright, so here's a more detailed explanation. There are some key aspects of a functional model that we should talk about. First, there's data flow. Functional models often use diagrams like data flow diagrams or DFDs to visually represent the flow of data through various operations and functions. Next up, operations and functions. These models highlight the specific functions or processes that manipulate data, showing how input data is transformed or processed to produce output. Then, input and output. Functional models clearly define what the system's inputs and outputs are, showing the data that enters and exits the system. Another important point is the focus on logic. The primary focus is on the logical operations and transformations performed on the data, rather than the specific data structure or storage. And finally, no control aspects. Functional models typically don't depict the control flow or sequencing of events, focusing solely on the data manipulation aspect. Okay, let's look at some examples of functional models. First, data flow diagrams, or DFDs, are a common graphical representation of functional models showing the flow of data through processes. Next, there's functional decomposition, which is basically breaking down a system into its component functions, each with its own input, processing, and output. Then we have use cases. In object-oriented analysis and design, use cases can be used to model how the system interacts with users and performs specific tasks. And finally, process maps. These are visual representations of business processes, showing the flow of data and tasks. So why do we use functional models? Well, the purpose of functional models is pretty clear. First, they help with understanding system behavior. Functional models help developers, analysts, and stakeholders understand how data is processed within a system. Next, system design and analysis. They provide a clear picture of the system's functional requirements and can be used to identify potential issues or inefficiencies. Another reason is communication and collaboration. Functional models facilitate communication among different teams involved in system development. And lastly, they serve as a basis for implementation, providing a blueprint for implementing the system's functional requirements. Thank you for joining us today. I hope you found this session useful. Please share and see you in our next session.